Okay, we're going to be graphing inequalities today. Um, and I know we're used to graphing stuff on the number line. Here we're going to actually graph it on a real graph. So there are a few steps, but it's going to be a lot like when we graph equations. So we're going to graph inequality using the same rules that we use when we graph equations. We will use a solid, so a normal line, if the inequality symbol is less than or equal to or greater than or equal to. We'll use a dash or a dotted line if the quantity is less than or greater than. And then we will shade part of the graph depending on what our sign says. So let me scroll down a little bit. Okay, so the next page, we have 4 examples. So we're still using y equals mx plus b. So here my b is -3, so I'm going to start at -3. So I'm going to write this down, b -3. My m was 2, which can be written as 2 over 1. So from this dot, you go up 2 over 1. Okay, so I have my dots, and you can make more dots if you want to. I notice that it's greater than or equal to, which means that it's going to be a solid, so a normal line. So we're going to connect the dots like that. And then we always shade part of our graph. So if I look at my problem, it says y is greater than or equal to 2x minus 3, which means I want numbers that are bigger than 2x minus 3. So here's my 2x minus 3 line. So I want numbers that are bigger, so I'm going to shade this way. So you just shade the whole graph. It doesn't have to be perfect, just so long as I know what side of the line that you are shading. So again, just because it said greater than or equal to, I want numbers that are greater, so up in the top part of the graph. You also could test a point. So I usually test 0, 0, and you plug in 0 for both of your values. So we get 0 greater than or equal to 2 times 0 is 0, minus 3, -3. This is true. So that's why we shade it over there. But I think it's just easier to think y is greater than, so shade where it's greater than. Okay, number 2, your slope is 1/2. And your y-intercept is 3. So start at 3, go up 1 over 2. This is just greater than, so it's going to be a dotted line. It doesn't have to be perfect. This says y is greater than, so we're going to shade where numbers are greater than, so up here. If it said less than, we would shade where the numbers are less, which are down here toward the negatives. Okay, moving on. Number 3, I like to write this with y first. I'm going to switch this around to say y is less than x minus 1. So my m is 1, which is also 1 over 1. My b is -1. So I start at -1, and I go up 1 over 1. Since it's just greater than, there's no line underneath, this is a dotted line. Again, it doesn't have to be perfect. And it says y is less than x minus 1, so I want numbers that are less than my line, so towards the negatives. Okay, and then last one, we want to get y by itself, so I'm going to subtract the 3x over. So we get -y less than or equal to -3x plus 2. I don't want a negative, so I'm going to change all my signs. And since I'm dividing by a negative when I do that, I'm going to flip my inequality symbol. So again, that's just like dividing by -1 for all of your terms. So here my m is 3, so 3 over 1. And my b, my y-intercept is -2. So I'm going to start at -2, and I go up 3 over 1. This is going to be a solid line, a normal line, because it's less than or equal to. So the equal to part tells me that it's just a normal line. So I'm going to connect them. And then I look and I see y is greater than 3x minus 2, so I want numbers that are on the greater side. Okay, so if you have any questions, feel free to email me. I will be available, so just send me an email and I will respond as quickly as I can.